Okay, let's talk about how to think about functions graphically. Let's continue with that function that we were just looking at that converted from Celsius to Fahrenheit. So what we're looking at here is on this horizontal axis, we have all the possible values of a Celsius temperature. All right, so I can vary those values back and forth. So that dot that you're seeing there is a particular value that I've chosen. Now for every Celsius temperature, we know there is a corresponding Fahrenheit temperature. I'm going to plot that on this vertical axis over here. So let's plot the corresponding Fahrenheit temperature. And then you can see as I change the Celsius temperature, the corresponding Fahrenheit temperature changes as well. And as we had determined previously, when let's put the Celsius at 10, we knew that Fahrenheit was 50, and that's exactly what we're seeing here. And if the Celsius temperature was at 20, we know the Fahrenheit temperature is at 68. And so we're seeing that. Now, this describes the function, right? The relationship between these two values. We have our input down here and our output over here. So, like we were saying before, the input we were calling x, the output we were calling f of x. And so that's what we're looking at, the relationship between x and f of x. That's what describes the function. But we can describe this a little bit more cleverly. What we can do is consider the point whose x-coordinate is the Celsius temperature and whose y-coordinate is the Fahrenheit temperature. So let's plot that point, and you can see it plotted here in green, and let's think about how that point changes as I vary the input, the Celsius temperature. And you can see that that point is moving along a straight line. That's this line right here. That straight line is the graph of the function, and it describes exactly what that function does. And so this is the graphical representation of a function. The point up here on the graph is the point x comma f of x for some choice of value x. And that's what the graph is. It's the set of all points x comma f of x for all possible values of x. And that is the graphical description of a function. Okay, great. Now let's use the graphical description of the function to answer some questions about the function. For instance, I might want to know what is the Fahrenheit temperature corresponding to a Celsius temperature of 40? All right, well, I'll imagine being over here at 40, right? Now, I see the corresponding point on the graph is right up here, and if I go over to the y-axis, I find myself at the corresponding Fahrenheit temperature. Now, I can't tell exactly what value that is, but I can estimate it, right? I know this is 100, this is 110, so it looks like it's about 104. Now, if we wanted to get the exact answer, we could do what we did previously with the algebraic description of the function, actually plug in 40 and compute the answer exactly. But I bet we'll get something close to 104. We could ask a similar question, but in reverse. What if I wanted to find the Celsius temperature corresponding to a Fahrenheit of 80? All right, well, I'll just position the Fahrenheit here at around 80, right? I'll go over to the graph and then down to the corresponding Celsius number, and I see it's between, looks like this is 25, 30, 35, 40. So it's between 25 and 30, maybe it's right around 27. So I can see that the Celsius temperature corresponding to a Fahrenheit of 80 is right about at 27. And again, you could use the algebraic description to get the exact answer, but the graph allows us to very quickly get an estimate. And that's how we can use the graph to determine values of our function. All right, so now let's take a look at a different function and see what we can say about it. Okay, so here we have a graph of a function. Let's say this function is called g. All right, so suppose I wanted to know what the value of g of 5 is. Well, to find g of 5, well, I make note that my input is 5, right? So to find g of 5, I go up to the y-axis. I have to go up to my graph and then over here, and that is the value of g of 5. What number is that? Well, that's 5, 6, 7, 8, 9. So I can say that g of 5 is equal to 9. Or in other words, 9 is the output associated with the input 5. What about g of negative 3? Well, if I go over to negative 3 and go up to the graph, I find myself again at 9. So the answer is g of negative 3 is equal to 9. What if I asked a question the other way around? What if I know that g of x is equal to 3, and I want to know what the x is? So in other words, I'm solving the equation g of x equals 3. Well, if I know what g of x is, that means I know my position on the y-axis. I'm saying it's equal to 3, so I'm right here. So I just have to find the corresponding x value. Well, if I go over to the graph and go down, I find an x value 1, 2, 3. So the x is also equal to 3. So the solution is x equals 3. However, there's another solution here, because I can also go to the left and go down, and I find myself at negative 1. So there are actually two values of x, negative 1 and 3, that solve the equation g of x equals 3. Now this is an important thing that you want to keep in mind. There can be more than one x value associated with an output. But one thing you'll note is that for every input, there will only be one output. For example, a picture like this cannot be the graph of a function. We see here that there are x values associated with two different y values. In other words, there are inputs that produce two different outputs. And a test to determine when this problematic scenario occurs is known as the vertical line test. If one can draw a vertical line that crosses the graph more than once, then it cannot be the graph of a function. In other words, functions will always pass the vertical line test. Any vertical line will intersect their graph at most once.